Alright, here you are in the last video for section 12.6. This is where we're going to be taking a look at the hardest type of all of these problems, which is strangely also the easiest type. We started with ones where there were exponentials on both sides as our first and easy type, but there was a trick that we were able to use there that we cannot use all the time. The trick was to get the same base on both sides and then cancel it out. Well, take a look at this equation. Can you get the same base on both sides? Absolutely not. 3 is the base on one side, 2 is the base on the other. There's no clever trick we're going to be able to invent to try to get the same base on both sides. So instead what we have to do is something much more complicated. It's going to be a kind of a tricky process. The trick here is to take a logarithm of both sides of the equation. Now, while you're thinking of that, realize that when we say a logarithm, there are a lot of logarithms. I mean, there's log base 2, log base 3, log base e, log base 10, all sorts of different logarithms. And if you're looking at this equation and you really understand how logarithms work, you might be tempted to use a logarithm either base 3 or base 2. And the reason why those might seem like good choices is a logarithm base 3 will cancel with 3 to the x minus 1, and you'll just have x minus 1. On this side, a logarithm base 2 would cancel with 2 to the x minus 3. You'd simply have x plus 3. You'd just have the x plus 3. But the problem is, since you'd have to do the same logarithm on both sides, you can't get them both to cancel cleanly and nicely. You might be able to get the left side to come out pretty, but then the right side would be ugly. Or you could get the right side to come out pretty, but the left side would be ugly. So ultimately, you are eventually, no matter what, going to have to use a calculator to work out your answers in the end. So let's just sort of accommodate to that from the very beginning. My advice here is use a logarithm that your calculator can work out. So either use log base 10 or use natural log, one or the other, because those will be on your calculator and you'll be able to work them out pretty nicely. For our purposes here, I'll use log base 10, but ultimately the answer comes out the same no matter which logarithm you use. So I just simply take a logarithm of both sides. So it'll be log of 3 to the x minus 1 on one side, and log of 2 to the x plus 3 on the other side. And then this is where the most important logarithm property of all comes into play, because these are the toughest equations, the ones that are going to give us the messiest answers and going to take the most work. This is the situation where you really have to know your logarithm properties. The most important logarithm property is the one that lets you take the exponent, peel it off, and put it in front of the logarithm. So that's what we do now. We take the exponent, we put it in front of the logarithm. Do the same thing with this exponent. Peel it off, put it in front of the logarithm. So what you should have would be x minus 1 times the logarithm of 3, and on this side you'd have x plus 3 times the logarithm of 2. Here's what happens next. This is a very strange topic from the point of view of a teacher, because from a theoretical point of view, what happens from this point on is very simple algebra. It's algebra 1 algebra, linear equation algebra. But it looks visually so complicated that students tend to panic. So what I want you to remember is that log 3, that's a number. You could grab your calculator, you could press buttons, and you could figure out what that number was. It's 0.47712125547, etc. Same thing with log 2. That is a number. But if you convert them into their decimal form now, you're going to be producing such a huge headache, it's totally not worth it. So even though log 3 looks like some fancy, strange, new sort of thing, the decimal, 0.477, etc., would be even worse. So we're going to leave it log 3 for right now. We'll get the calculator out when we're all done rearranging things. What we do is we take that number, like we would any other number, and we distribute it in. So log 3 is going to get multiplied by x and multiplied by 1. Over here, log 2 is going to get multiplied by x, and it's going to get multiplied by 3. So we're going to have x times log 3, and technically, since that's the number, it's kind of the coefficient, I would normally write it in front of the x, but think about what that would look like. If I wrote it in front of the x, is that log of 3x? No, it's log of 3 times x. It's not log of 3x, and it's really hard to visually see the difference between those two things. So just to make it easier not to get confused by what we're writing, we actually put the log 3 second. Now it's obvious. Is the x inside the log? No, it's out in front of the log. We're going to use the same sort of trick on the right-hand side. When we go x multiplied by log 2, we're going to leave the coefficient to the right just because it's kind of cleaner there. And then what you're looking at here, although the logarithms disguise it, this is just a regular equation like you've studied many times in the past. In fact, for comparison, imagine if you had, say, 10x minus 4 equals 3x plus 7. You would know what to do there. You'd know you're going to collect your x's on one side and move the numbers over to the other side, and you'd probably have to divide eventually. Well, this is the same thing. This is something times x minus something equals something times x plus something. So we're going to use the same tricks. We're going to move this over to that side, and we're going to move this over to that side. So what that's going to produce will be not quite as clean as it would have been with regular algebra, back over there, but it'll be a similar sort of thing. We're going to have x log 3 minus x log 2, and on this side we're going to have log 3 plus 3 log 2. Remember, this one moved over to here, and this one moved over to here. They used to be on the other sides. The last couple of steps of finishing this thing up are pretty straightforward. Here, factor out the logarithm. Oh, sorry, not the logarithm. Factor out the x, and that thing in parentheses there, log 3 is just a number, log 2 is a number, this minus that is some decimal point something or other. X times this, that's effectively the coefficient. We're going to divide by it. So we get x equals this fraction here. And the interesting thing is, there are plenty of times where this itself is a very acceptable answer. If the question wants you to find an exact answer, and make sure you read the directions, this is what the directions say sometimes. Sometimes they say find the exact answer to the equation, and then you have to find the exact answer. On the other hand, may want you to do a decimal answer, and I think you're probably more comfortable with the decimal answer. You probably feel like this problem isn't finished yet. So if the question wants you to say round to, let's pick a number, let's say round to 4 decimal places, well, then you've got some more steps to go through. What you have to do now is actually use the logarithm buttons on your calculator, and so on and so on and so on. I'll give you a little bit of a hint here. When you're typing this into your calculator, you're going to need to have some extra parentheses in there. What you're really going to be having the calculator do is your calculator is going to be working out this arithmetic here. And if you don't have the parentheses in there, then it's only going to be dividing these two parts here. You want this whole chunk to be the numerator, and this whole chunk here to be the denominator, so these parentheses are essential. So when you go to type this into your calculator, type it in like this. Well, unless your calculator is one of those ones where you have to swap the order around for the logarithms. So there's a possibility you might have to do these logarithm parts differently. But experiment with your calculator. See what it takes to get the answer here. I'm going to work it out on my calculator. So pause the video and then press play when you're done and see if you get the same answer that I get. Man, that's a lot of typing, isn't it? That's one of the reasons why this is the hardest type of the problem. It's not just that the algebra is hard. It's also that there's so much typing at the end that it would be real easy to like forget one parenthesis somewhere or forget one symbol that was essential. So to 4 decimal places here, you should be getting 7.8380. The next digit after that was a 4, so we're rounding down. And remember, with exponential equations, you are not required to check your answer. Checking is optional. The way you would check this is you would take 7.8380, you would go back to the original equation and plug it in on each side and see if you get the same thing. Because it's a rounded answer, when you work out on your calculator the left side and the right side, they won't match perfectly, because that's the difference between exact versus approximate answers. An approximate answer is not perfect. So this is definitely the toughest equation type we have to do here. The steps may be, in a sense, normal algebra, but the symbols make it so confusing that people usually get lost somewhere around here in the middle. So take your time, go through it very carefully, one step at a time, and as long as you respectfully take the time that it demands of you, you should be just fine.